Hi dear students, welcome back to a new video of I Square. Today in I Square we are going to discuss about one of the most important function from the chapter relations and functions, and the name of that function is nothing but signum function. And many of you have learned about the basic definition as well as the graph of signum function. Even you don't know what is signum function and how the graph arises. In this class we will explain signum function in detail about the basic definition and how the graph of it comes and how it related to modulus function. These three aspects of signum function will be discussed in this class. Basically, a signum function is denoted by f of x. So f of x is equal to, signum function has three basic values, 1, 0 and -1. The value or the output value, precisely we are speaking about output values f of x, and the output value equals 1 for all input values which is greater than 0, or for all positive values the output value is 1, and the output value is 0 for all values which is equal to 0. That is, 0 is the only input value which gives the output value 0, and the output value is equal to -1 for all negative real numbers. That is, for all negative input values the output value will be -1. So this is the basic definition of signum function. For example, in a signum function, suppose that we are asked to find f of 2. We know that signum function is 1, or the output value is 1 for all input value which is greater than 0. So f of 2 is nothing but 1. Similarly, f of 3, it is also a positive number. Input value is a positive number, so f of 3 must be equal to 1. Similarly, f of 5 is equal to 1, or f of 10.2 is equal to 1, etc. Now, suppose that we are giving the input value my negative number, that is f of -3. Definitely input value is a negative number, so the output value will be -1. Similarly, f of -8, again it is equal to -1. Similarly, f of -10.5, it is again equal to -1. Similarly, any input value which resulted in a negative input, the output will be -1. So this is the basic definition of signum function. So we shall discuss about the graph of signum function then. Now, as you know that in the x-axis we plot or we mark all possible input values, that is, each and every point in the x-axis denotes an input value, isn't it? So whether it be a negative number or a positive number or even 0, it denotes input value, whereas each and every number in the y-axis denotes output value. As you can see that signum function has only three output values, 1, -1 and 0. So it is needed or it is required to mark only these three values in the y-axis to draw the graph of a signum function, because signum function has only three output values. In the y-axis we denote output values, hence we marked -1, 0 and 1 on the y-axis. And since signum function can have any real number as input value, we can have any real number in the x-axis as input value. Now, let us look back to do the definition. Since for any number greater than 0, as you can see that for any number greater than 0, the output value will be 1. That is, if the input value is this point, then the output value corresponding to that number will be 1. Again, if the input value is this point, it is greater than 0, so the output value will be 1 again. And for any real number in this direction or in the right side of 0 will result in an output value 1. Therefore, we can directly draw a straight line which passes through all these output values, which gives, all these input values which gives an output value 1. That means all those real numbers to the right hand side of 0 gives us an output value 1, and if we draw a line passing through those output values, we will get a straight line which passes through 1 to the right side of the coordinate plane, as you can see in the figure. Now, As you can see that for any real number less than 0, the output value is -1. That is, if this is the real number, then the output value is -1. And if this is the real number, the output value is again -1. If this is the real number, the output value is -1. And it goes on like that. That means any number to the left of 0 gives us an output value -1. And if we join those points, we will get a straight line like this to the left of 0. And as you know that whenever the input value is 0, the output value must be 0 then. So we can mark 0, 0 as a point. That means if the output value is 0, then the input value must be 0. So 0, 0 is a point. Now since we already chose the output value at 0 as 0, we cannot choose this point since this point also corresponds to 0 in the x-axis. So since x-axis 0 gives us the output value also 0 and we chose that here, we cannot choose the 0 number at the y-axis. So we have to show that by a white circle or bubble in order to show that here the 0 in the y-axis or the 0 corresponding to the input value x-axis is excluded from this straight line. So this must be shown using a bubble. Similarly, we have to show using a white bubble that 0 is excluded from this line also, so that we have two white bubbles at the end of each straight line which runs parallel to the x-axis, and we have a darkened bubble at the origin to show that whenever the input value is 0, the output value must be 0. Now we shall derive the connection of the signum function with the modulus function. As you know that modulus function is also defined in two ways. We know that mod x, the function mod x is defined by x when x is greater than or equal to 0 and minus x when x less than 0 and 0 for x equal to 0. We know this. So this is the modulus function and we can easily find modulus of x by x equal to x by x when x greater than 0 minus x by x when x less than 0, 0 by x when x equal to 0, isn't it? So this is the modulus x by x value. It is again equal to x by x. We know that it is equal to 1, isn't it? So x by x is equal to 1 when x greater than 0. Again minus x by x. We know that it is equal to minus 1 when x less than 0, and 0 by x result in 0 when x equal to 0. See, whenever we consider mod x by x, we resulted in 1 if x less than greater than 0, minus 1 if x less than 0, and 0 if x equal to 0. And this value is nothing but signum function. That is, this is equal to the signum function. So signum function is nothing but modulus of x by x. So we can denote signum function by this single definition, or even we can denote signum function by this definition, mod x by x. Both these definition result in this definition also. So we have the graph of signum function like this, definition of signum function like this, and even we saw that signum function even can be denoted by this definition also, since mod x by x result in the same definition as that of signum function. So this is the basic concepts you have to know about signum function. If you know this concept, you can score all questions regarding signum function, and signum function is considered to be most of the frequently asking question areas from the chapter relations and function. So in the next video we shall come with new and important topics from different chapters. For that you have to stay tuned for these videos. Bye bye.